Hello, our project was the Falling Sand project, and this is our tech talk. The project was completed by Joshua, Tanisha, and Marilyn, and our mentor was Charlie Liu. So, for the objective of our project, we wanted to imitate a website called Sandspiel, and basically on this website, there were a bunch of elements that you could click on, and there were elements such as wind, wall, oil, rocket, fire, acid, and sand, and there were many more. But the idea was that these elements would interact with each other just like they would in nature. So the fire would become smoke when it interacted with water, the acid would dissolve all of the particles, and then with things such as like when you drew a wall, the particles would act according to the laws of physics, and the particles would fall on it or around it. So our goal was to make the website as realistic as possible, just like this one. But we wanted more of a purpose behind the project other than just clicking and having particles fall around. So we geared it towards two audiences, one to calm children who are at home during the pandemic and who are kind of just at home and they're really bored. And the structure allows them to calm down by clicking on the canvas. And also, we realized that this project is very therapeutic and it gives off therapeutic sensations. So we also geared it towards people with anxiety issues so they can play around with this tool for a while and it could take their minds off of whatever situations they're in and then also de stress. And this was emphasized by the website's simplistic design. So this is our product. As you can see, the background is very simplistic, and as for the letters, falling sand. And then from the drop-down menu, we have the materials. So we have sand, water, and then erase. So as you can see, the sand falls, and then if it hits the barrier, then it will act accordingly. It will either fall on it or around it. And then same with the water. And then the erase function allows you to erase the particles that have already fallen. And then the barriers are just there for like, if you put a material on it, then it will fall according to physics. So for the design and website layout, first, our site is static, which means that the content on the web page is fixed. There are no user login systems or code that is changing. So we coded it on front end using JavaScript for graphics, and we decided not to have a back end because there was no need for it. And also, it was deployed with Netlify, and we had pull requests to put it on the production branch of our repository. And the pull request, we would check the code and then make sure that nothing was wrong, and then we would deploy it. And the site was designed in Figma, which is the interface design tool. And we wanted to give it a calming feel and a really minimalistic design. And then also, as you can see from the previous slide, there was a gradient background, kind of the blue, that kind of is very calming to look at. So when we completed our project, we realized there were many strengths to it and things that we just enjoyed. So first, the particles like water and sand interact very realistically. And what we mean by that is when you click, for example, the sand, it falls, and then the barriers, they act accordingly. And then after the sand falls, if you put water on top of it, we wanted them to interact just like they would in real life. So the water kind of dissolved the sand, and also, when you clicked water and it reached the ground, it would still be moving just like it would in real life. Another strength is that our interface is very easy to interact with and view. It just requires a computer and a mouse. You can even run it from other devices such as an iPad or phone. And it's just very simple and there's no complicated steps to use it, and anyone can basically use it. And again, it's very pleasing to the eye. And basically, any age group or any person can interact with it, enjoy just playing around with particles and just seeing what we've created.
So the main issues that we ran into were developing a way to get the particles to stack and collide and decreasing lag. So at first we had the sand and water particles and they would fall one at a time, but they would overlap instead of stacking and colliding with other objects. And another issue we ran into was after we got them to stack and collide, it the method we used had a lot of lag, so the particles would fall, but as you had more particles on the screen, they would fall slowly, which really reduced the calming feel of our interface. So first we had to focus on the particles colliding with barriers. So the particles fall at 3 pixels per second, and at each stimulated frame, possible collisions with the barriers are checked, and you can see our code below where they check the right and the left through these different methods. Each particle occupies a 5 by 5 pixel block, and so you can see in this section of code how we check the collisions by checking the x and y direction and if there are any particles around it, so that if there is a particle, it'll stack on top instead of occupying the same pixels as another. This creates the building visuals, as you can see in our website. The particles are considered stopped after 30 frames of not moving, which allows for more efficient calculations because the, the website doesn't need to account for the particles that aren't moving anymore. And the particles don't stop falling midair unless if there is a particle beneath, then they'll have 29 more chances to move, and this is demonstrated through our stop strikes variable. Particles stack. Well, the particles stack sand and water. The sand stacks when the bottom left, middle, and right are taken. Otherwise, they fall into the next available space. And the water is similar to the sand, but the water has to have sand on both immediate sides before it starts rising. Lag prevention. P5.js is really expensive. It uses a lot of time and it causes a lot of lag. The same with load pixels and pixels in P5.js. Even though it uses less lag, it's still a considerable amount. So instead we used a height by width 2D array that kept track of all the particles that were spawned and their locations, which significantly reduced lag.
We also implemented an erase function, which you probably saw in the GIF that was a few slides ago. This basically looped through all the particles and checked if it was in a circle, if it was in a circular area from where the reverse click happened. And if it was, it would just remove it from the global particle array. One thing that we also implemented was the drag and drop barriers. How this worked was basically if a click was registered that was inside a rectangle, then that rectangle would start moving around with each change in position from frame to frame along with your mouse. And finally, one minor bug that we had was if you clicked outside of the canvas, it would still spawn particles. So the way we fixed that was just by adding an if statement. So in conclusion, from this project, we all learned how to communicate in a team. We use professional tools such as Slack, Netlify, Trello, and GitHub in our workflow. And we also learned how to use GitHub to effectively collaborate on code together. And we also learned P5.js for the graphics, of course.